Ladies and gentlemen, it is 3 o'clock. Welcome, my dear micromachining friends. Welcome to the online laser micromachining event of the year. On Monday, May 17th, we put the spotlight on laser micromachining because these small but important tools drive our world. But why are lasers such brilliant tool makers? Because they enable us to make very small parts in a highly accurate and repeatable way. We can perform micro-precision etching, surface smoothing, ablation, micro-welding, hardening to create beautiful micro tools. Look inside a fine mechanical watch. You will agree that these tools are the pinnacle of human engineering. In this epic online technology meeting, I want to involve the end users who really need these micro tools. Our guest list includes major suppliers of micro tools, such as MPS Microsystems, luxury watchmakers IWC or Swatch, as well as highest-end car maker Ferrari, or even suppliers of microfluidics for analysis of metal traces in water like Clearia. We can't forget semiconductor giants such as Infineon, where the accurate laser micromachining of semiconductor materials has become an essential part of their process. In addition to the end users, our meeting will involve 3 different groups of key people. First, we have the providers of the ultra-fast laser solutions, essential to any process. Ultra-fast lasers, pico and femtosecond, have progressed enormously in terms of stability, power and pulse repeatability. I am extremely impressed by the developments of Oxford Laser, Lithium Laser, Fluence, Lumos Laser, Phantom, Fiberchrist. I can't mention you all, together with the giants Coherent, soon to be 2.6. Then we take the laser beam and we scan it. Remember our virtual visit to Augmented? They showed us the importance of accurate beam scanning. And you need to scan the right beam. And talking of which, I am constantly amazed by the beam shaping work of Kioba, Kylabs or Fisba. And last but not least, the micromachining industry is becoming highly automated. So we also need to address an important group of people who are developing the workstations to understand their vision and their needs. We will have in the room iconic companies in that respect: George Fischer, Pozo, and Turner Laser Systems. Everyone is going to be there, from the software control provider Direct Machining Control to the service provider Microrelleus. Do not miss the micromachining event of the year. If you want to propose your company's solution, then sign up now, because you need to discuss with the other experts in the Epic Zoom room during our meeting on Monday, May 17th. The world is a better place thanks to micromachining. The world is a better place thanks to micromachining, and the world is a better place thanks to you. After working very hard on this topic for the last weeks, we managed to really put together a great supply chain. And on that, I would like to thank our laser expert and better friends, Dr. Francesca Moglia. Francesca, fantastic job you have put together. Epic is you. Epic is the people who love photonics. We are now more than 700 companies, and we dedicate our life to organize events, provide access to a network, help you raise capital. We have the biggest website to find a job in photonics, jobsinphotonics.com, and we help you analyze the market with our fantastic market reports. Today, laser micromachining. But in a few weeks, we're going to have an amazing event on VCSEL manufacturing and applications. Mark it down with the top VCSEL manufacturers and end users on this very planet. But today, laser micromachining. So first of all, I would like to thank our media partner, PhotonicsViews. Thank you for the amazing job you're doing promoting all our activities. And also, I would like to thank all fantastic companies today in the room. DMC, Direct Machining Control, all the way from Lithuania, to provide the software for the control. So for the control of the workstations, materials, Balzers, optics. You're looking for a supplier of high-end materials, of optics and filters for your laser optics. Balzers Optics is your partner. We We go to Lithuania, we have workshop of photonics, developing services and workstations for the glass processing and advanced laser-based manufacturing. If you're looking for laser optics or crystals or non-linear elements for your laser, Eksma Optics of the Lithuania, they are your fantastic partner of that. Fluence Technology in Poland, they develop 150 femtosecond lasers for the laser micromachining world. And if you need to measure them, Laserpoint develop the fantastic power meters on this industry. Also OPTOMAN, if you're looking for a partner to provide you ion beam sputtering based optics, IBS coatings for your laser optics, OPTOMAN is the great player, and you're looking for a partner. Or the ultra-fast laser system, EdgeWave is your partner on this. And my partner on this is Dr. Francesca Moglia. Dr. Moglia, what's going to happen today?
Thank you very much, Jose. Thank you very much for the introduction. So here we see the agenda of our meeting today, but this is the boring version of it, right, Jose? Exactly, because the one we want to show is this one that doesn't only show the people who are speaking officially, but also all of you who sign up for this meeting, and you are very free to contribute also without having slides, so just being lively in discussion. And as you see here, we have a good distribution. So we have 4 big areas. So of course we see laser micromachining is this really interesting topic. So that's a very good feedback for us, for end users of all possible different sectors. So we are welcome, and you are very welcome also to tell a bit your expectation and your needs and challenges. Then there is a big block of laser workstations, and that is of course very important for us that you are interested in joining today. Then a laser workstation for micromachining users, usually we have ultra-fast lasers, so that's why this is a big family also of people present here, but lasers in general also present. And then manufacturing services. So we see this is the other big, large family of participants today, addressing all the possible services connected to laser micromachining, of course. But then let's not forget all the other parts that build up a machine that and then is useful for the laser micromachining. So we have process monitoring, we have the laser fiber amplifiers as well if needed, the softwares, materials is important, and basically we filled up the full supply chain of this topic today, not forgetting the R&D, of course, the micromachining of the future. But let's go back to Jose because we have to start.
You know, Francesca, one of the biggest challenges is to present this slide in seconds. I'm amazed how you keep doing that. This is fantastic. We keep innovating at EPIC. Today we have a fantastic agenda, so we thought, why don't we split it in 4 groups in which we plan together 2 companies who we think should work together. So how we're going to do it? We're going to have 4 slots of 2 companies that EPIC wants to link to develop a project together. And the role of everybody in this room is to help this happening. This is going to be a fantastic meeting, and which is also live streaming YouTube. So let me say hello to YouTubers very fast. Hello, YouTubers of the world. If you want to have any kind of interaction with the participants today, drop me an email, jose.pozo@epicdasaso.com, telling me what you want to do with them, and I'll make an introduction. If you have any questions in the meeting, please post it in the chat of YouTube. And of course, this is also valid for the people here with me in the Zoom room. We have an internal chat, so use it. Use it to talk to each other and make sure you do business. If you want to get in touch with any of the participants after the meeting, drop me an email and I will for sure make the introduction. And that was the introduction of this meeting. So now is when the business gets started. I would like to introduce the first 2 speakers of the meeting today. We have an end user, Royal Canadian Mint, developing coins, medals, and we have one of our key companies in EPIC developing process for the femtosecond and laser-based micromachining. The service provider of femto and picosecond laser-based processes, Microrelleus. So welcome these 2 first speakers in the room. First, Xianyao, thank you very much for being with us, taking the role of end user. The floor and the attention of everyone goes to the Royal Canadian Mint.
Thank you so much. Thank you very much for inviting me to join with a group of experts. So I'm going to share my screen and hope you can see my screen now. Have you?
Yes, crystal clear.
Great, thank you very much. That's great. So yeah, and we're very happy to be here. And as the end user, I really appreciate the opportunity to listen to all experts here. Thank you. The Royal Canadian Mint is a commercial crown corporation, Solely owned by the government of Canada. Our mandate, of course, is to produce Canadian coins and manage the coinage system for the country. Founded in 1908, the over century history and experience have earned our reputation in innovation and technology in the minting industry. We have two facilities. As you can see here, one is in Ottawa, Ontario, where our head office is located. And also we have manufacturing plants not far from actually Canadian Parliament. We are producing numismatic, connectable coins, bullion products, metal medallions, as well as silver and gold refinery right in downtown of Ottawa. So another facility is located in central Canada, Winnipeg and Manitoba, where we produce all Canadian coins. Believe it or not, we actually also produce coins for other countries. So far, we have produced coins for more than 80 countries. So I know you all are expert in photonics and micromachining. So you may have already known that micromachining, especially using laser process, have already been used in our industry. Of course, this has become part of our manufacturing process, especially for coating dies at the Royal Canadian Mint. If I may, here I have grouped 4 major applications for minting. The first group is laser application directly on coins. As you can see, 3 coins here. They are gold coins. We like to put some special features on the connector gold coins without compromising the purity of gold. For example, our customer has asked, are you able to produce a black gold on gold without compromising the 49 gold? Of course, I'm a metallurgist. From a material point of view, yes, if you're going to add some alloy elements, you should be able to change the color of gold. However, that intermetallic compound will be very, very brittle. If you're going to use a stamping dies to do it, they would have shattered. So you won't be able to form coins. How are we going to take these challenges? Our engineers came up with a very innovative approach, using laser to create a special surface textures so that the light reflection is altered to only show black and gray area. If you're going to put this coin into chemical analysis equipment, for example, scanning electron microscope, you will only see the gold content. You don't see anything other than gold. So by this way, the gold purity has been maintained. So we also show the special features. So this is something we have using the laser process directly on coins. We are also able to use laser to create the photonic colors or structure colors. I'm not sure if someone has already seen some of coin samples or presentation we did at the World Money Fair in Berlin, Germany. We presented the photonic coins that we used the laser process directly create nanostructures to show fixed colors. This is one of the examples showing here. The second group of the application is to use the laser to produce the coding dies by which holographic images can be stamped, transferred onto the coins. Here I show you some examples of coins. Have you seen some of the gold coins showing the holographic pictures? Something like this. We're able to create the 2D, 3D, or even multi-channel for images on the precious metal coins. So if you, again, similar like what I talked about earlier, the gold coin, if you're going to check the silver, there's no any second element is a pure silver. However, we're able to create the holographic, beautiful, images, designs onto precious metal coins. And the way we're doing is we create a special die and use the die to transfer the holographic images onto the coins by stamping. So that's the second application. For the third application is the core business of our minting. We use the laser process to create ultra high relief or high relief or extraordinary high on metals. We use that metal as the die to strike different kinds of coins. So we have two major applications. One is to use a laser to do deeper engraving. Another way we're using is to create a special aesthetic contrast to show the different frosting effect. So that's the way we are using the laser to create the coating dies. The last group is a process we use a laser to create the special unique security features. As you know, coins and also any monetary products are very important in terms of security, in terms of how to fight counterfeitings. So we use a laser process to create the special features, and then we combine with other technology to create the special security features. So those are kind of four major applications. Going forward, I know you are experts. I'd like to see if you can help us to improve different areas. For example, how we are able to improve the quality of the dies we created. So some of the pictures showing here, we still see some of the burns, oxides, sometimes even some micro cracks, which are not good for subsequent process. For example, PVD coating on the coating dies in order to improve the die life and also the quality of the coins. So if you can help us, that would be fantastic. Of course, another area I'd like to see if you can help. Are we able, even though we have mentioned about the holographic images, are we able to create even more dynamic features? Something to show Canadian beautiful northern lights, for example, right? So we can have some animation images, no matter if it's color or grayscale. That would be fantastic. So I've shown some pictures here. We have done some pulsating effect. Are we able to do even more? You're experts. I'm sure you can find a solution for us. And of course, for other applications, right? So, and security feature, the fight against the counterfeit is never ending. I'm sure you know that, right? So it's just a matter of time. Someone may be able to copy what we have doing. So we like to increase our enhanced security feature as much as possible. So what will be the security feature 2.0, 3.0? That's something we really need some help from you guys. Lastly, but not the least, what kind of surface features can be created on coins so that the physical and chemical condition of the coins can be modified, can be improved, so that we don't have to worry about contamination. So when the people would be free to use the coins even during the pandemic, because you help us to create some special surface textures, the moisture would not be able to stay on the coins. Can you do it? That's why I'm here. I like to listen to you guys. I like to listen to your expert ideas so it can help the Royal Canadian Mint, help the minting industry. Thank you. That's all I have for today.
Thank you very much, Xianyao. I am truly amazed. We are going to have a Q&A round. What you presenting and what you ask in terms of counterfeiting instead of moisture not adherence, we had discussed in our previous event. We had the solution here. But first, we are going to go to our next speaker of this first round, and it's going to be the CEO of one EPIC member that provides femto and pico laser-based surface structure and other micromachining solutions, Raúl García Blázquez, all the way from beautiful Barcelona. Raúl, thank you very much for being with us today. The floor and the attention of everyone goes to you, and I know you loved the previous presentation. The floor is yours. I think, Raúl, you are muted, and that's good because I have a Mac to celebrate such accomplishment. Please unmute yourself. We have you muted, bottom corner of the Zoom window. Raúl, you are muted. Yes.
Okay, now I had some problem with here, sorry.
The problems are solved, the floor is yours.
Okay, thank you so much, Jose, for the introduction. Yeah, I'm really glad for the previous presentation because some of the points are very close about what we are doing. So first of all, I am Raúl García. I'm the general manager of Microrelleus, and in this meeting, I will explain a little bit what we are doing in terms of femtosecond laser processing and service. Okay, so I will speak just 1 minute about who we are and what we are doing, what a femtosecond laser is, really fast. Then I will speak about some functional texturing, microstructuring, and finish with some small cases study. So we are a workshop, we are a service provider for industry. What we do is industrial engraving, laser texturing, and laser microstructuring using mainly nanosecond and picosecond and femtosecond lasers. We are in the market since 1983, and our facilities are in Barcelona. So most of you already know what a femtosecond laser is, but for those who don't know, it is an ultra short pulse duration laser. There is almost no thermal effect over the material when we are engraving. So that's why we can achieve a clean, sharp, and burr-free micromilling with high quality surface finishing. So it is an optimal technology for microcavities in mold, microfluidic channels, microstructuring, stamping tool, microengraving, and so on. In the sketch, we can see a comparison between the affection of the laser on the material of the nanosecond versus the femtosecond, where we have a burr-free and clean ablation. So those are some projects that we have done in the industry, sometimes working directly on the part. We can see the first example, microstructuring for medical device. If you compare the engraving with the fingerprint, you can see how small we can arrive, how small we can work with very good quality. Self-lubricating microstructuring on steel tool, on lighting and micro-optics, both in insert, but also in final part for prototypes mainly, light diffraction textures, suprahydrophobicity, and so on. In this video, we can see the image, the effect of a water drop when it works with an area that was texturized with this micro and nano structure on the mold. So in this case, we work on the mold, the plastic injected replicates the structure, and we have this, this behavior in the final plastic part. The same in light diffraction. Here we can see a small video of the effect of this nano and micro texture in the mold, and also in the final injected part where we can see that we can find the effect as well. Some other possibilities to achieve pitch skin effect on plastic, working from the mold, soft touch effect, anti-scratch, or in terms of design, we can do limitless design possibilities. All of those examples are engraved on the mold and plastic injected on it. In lighting, we can do texturing, control texturing for light homogeneity to avoid hotspot of the LED or to achieve controlled homogeneity in one direction, in two direction, not just in small and flat parts, but also in big mold inserts, standard inserts of steel over 3D shape as well. Here we can see an example of the previous point of our customer, a nice company in the Basque country, Disalux, where we did this free-form micro-optics. And we can see here even a simulated value and the measured value of the injected final part. I will finish with 3 fast cases study where we used nano or femtosecond lasers to achieve something. In this case, it was a design texture, but for a functional purpose. So the radar of this car was placed behind the logo, so there was no metallic part allowed here. So we analyzed aluminum with confocal microscope, then we imitate this texture in the mold, so the final plastic part is from plastic and not from metal. So that's why the radar can work properly on its function. In the second example, it was for our customer, the Polytechnic University of Catalonia, and they wanted us to engrave directly glass, as femto is this cold ablation. We can engrave over any material to obtain a micro pattern for a microfluidic device. So the ablation was done with PS particles for mimic tumoral cell separation, and the micro pattern was totally functional. As a last example, in this case, micro optics for automotive industry, the customer wanted to place an LED on the top of a tail lamp of this car, of the Cupra Tabascan, and we did the engraving of thousands of microstructures to achieve this light curtain in these tail lamps. So the idea was to evolve from uniform lines to uniform surfaces. So those are the 3 small cases of study I wanted to present. And as I arrived to the 6 minutes, I am here to answer your questions. Thank you so much.
Thanks a lot, Raúl. Thanks a lot to Xianyao before. So thanks a lot for this. And let's say, here I would say the 2 speakers in a row are not by chance, right? So let me share first one more, the slide that we had before from Xianyao. So you see it here, I guess, I hope. I'm not good in sharing, but I hope this is a good one. So this is the slide that we had at the end of the talk of Xianyao. And these are basically what they're looking for. So usually we ask, for those who are not familiar with an EPIC meeting, we always ask the EPIC questions that are, what can you do for them and what can they do for you? So of course, Xianyao is a bit high in the supply chain. So he has clearly a what can you do for him? And so that is the list. So I would say that maybe Raúl can already comment on these slides, right? So how can you help Xianyao and the Royal Canadian Mint?
Well, we have some experience in similar projects like this one. And regarding smooth and clean surfaces that you were speaking about it, to minimal oxidize and so on, our experience is that this is quite dependent on the steel, on the material. So changing the steel, we are having different results. Okay, but yes, we have worked in close similar projects in die for die production, and especially on micro engraving, hidden microtext, these kind of things. So this is something that, yes, with the femtosecond laser, as you know, we can achieve with some limitations, but with some other new opportunities, of course. And maybe we can speak in the future about that.
That's great. Thank you very much. I think a good point. If we're going to choose a different type of steel, we would be able to have a different surface quality. But on the other hand, for the minting coating dies, right? We need to have at least medium alloy tool steel, and you have the carbides, and you have different kinds of distribution for carbides. That's something that we probably also need to pay special attention. So, and definitely I'm going to reach out to you for some of our experience and see if you can help us to improve the quality. And the presentation you just did was about the femtone laser. So we don't have a femtone laser, and the laser process we have is picosecond laser. Well, compared to the first generation of laser nanosecond, of course, the picosecond is much better, but still not that good enough yet. So, and maybe the femtone laser is something that we can look into, but definitely I will reach out to you. Thank you very much. Thank you.
Thank you so much.
Oh yes, you can reach out to him, and then you can reach out also to all the femtosecond manufacturers that are in the room now. And then of course, Sarah can be free to raise their hands. But before going to them, I have already some hands raised and some questions in the chat. So I would start with Juha from Oplatech, because he was the very, very first one. So maybe you can ask your questions, Juha.
Okay, this is actually for all of you. I would need on pure silica, just a slit or a tiny little opening on aluminium or chromium or whatever. If anybody here present would be able to do that, please contact me personally via chat or email or LinkedIn, whatever. I think there's a lot of people here knowing about micromachining and would be able to provide me that. Thank you, Francesca.
You're very welcome. And then you can connect us also asking us. We have always the contact, but of course, feel free to join, to reach out on LinkedIn, on everything, on in the chat. Yes, so very good. Then we have a question in the chat from Coherent. Sorry, I forgot your name, but I know it's there. Let me check.
Sorry, it's Dirk Müller.
Dirk, exactly. Thank you.
Hi.
Dirk, we usually ask to then ask the question yourself, so please feel free.
Thank you. Thank you. Good morning, good afternoon. So this is a question for Raúl. Thank you for the nice application slides. So I have a question regarding the longevity of the hydrophobic behavior. How long does the property last after you machine it on a metal or another material?
Yes, thank you so much. All the projects that we have done in this specific texture, because it is very, very specific one, were for R&D projects, okay? So there is no one on production because of this limitation. Of course, it is a very sensitive texture, both in the insert and also in the plastic part. So if you probably know that if you touch a lot with your finger, the plastic part will be affected, and the effect will be not as good as the beginning. So we are quite in an initial point here, because even we have done, I would say, around maybe 15 projects with that. All of them were for R&D. So unfortunately, we don't have data about that.
Okay, but maybe you can discuss this later, right? And get
Absolutely.
the information. Very good. So now it's time for Sabrina, Sphericon. Thank you for being here and for your question. You're muted, you're muted. Jose will show you the mug otherwise. There you go.
All right. No, I just hit the wrong button. So thank you to the two speakers again. That was very interesting. And I don't really have a question. It's more like a comment, especially to Xianyao, that if you would like to, or let's put it this way, that some of the things that you had on your wish list could maybe be addressed by having a look into the laser optics you are using. Because there's a lot of things that you can improve, especially if you would like to have a smoother structure by using beam shaping or special optics that give you a tinier surface or a tinier spot on the surface. So maybe we can be of help at one point, and I think it will be a good idea to exchange contact details, and then we can exchange what you already have and where we see a point for improvement. So yeah, that's the only thing I wanted to address. And one more thing, today is Aspherecon's 20th birthday, so party on.
I was about to say that. I was actually typing it. Congratulations and happy birthday, Asphericon, one of the key companies in Europe in the development of aspheric and freeform optics all the way in Jena. We love you. Continue the fantastic job that you are doing. Happy birthday.
Happy birthday also from my side. I read it as well this morning. So now it's time for Dariusz, Fluence, ultra-fast laser. Not a picosecond, right?
No picosecond, but actually you can tune to picoseconds as well. Hi. Yes, I just wanted to also make a comment, because to you have from Oplatech and to Royal Canadian Mint as well, that actually I wanted to show you a slide very quickly. Because if you need these applications, like you just said, you want them to be tested, just like small news from Fluence that we just opened our new application facility in Wrocław in Poland, where we have femtosecond laser, which can be nicely tuned from 200 femtosecond to 20 picoseconds. And we have like a lot of nice equipment going with it. Galvo scanners, all necessary optics, so we can do really nice demonstrations. We want to be close to our customers, so we want to show you that what can be done with femtosecond lasers. So if you have any questions, if you have any problems, you can always talk to us, and we'll try our best to make you happy and show you how femtosecond laser works and what it can do. So yeah, thanks.
Well, thank you very much, and also Sabina, thank you very much for your previous suggestion. I will make list and make a contact and send to you. Thank you. And
Xianyao, it will be a long list. Maybe you don't have enough paper to prepare for this list. Now, for those of you who are like me that still writes notes on the paper, you can still have your laptop. I agree on this. But now we maybe go on. So questions in the chat. So I kindly ask Andrew from General Atomics to ask the question himself.
Hey, Raúl. Thank you for the presentation.
Hi. Welcome.
Thank you for the presentation. One of the things I've been working on is getting micron level features on optical surfaces. So I might want to put fine steps or fine waves, but I want to start off with an optical surface and end with an optical surface. So just how smooth can you get it?
Yeah, Raúl? Yes. Now I'm
yeah, sorry. Can you please repeat it? I have some problem here.
Hey, Raúl. Yeah, no problem. I need to make some features on glass surfaces and other optical materials, of course, but I want to put things like fine steps or fine waves, where we're taught fine means measured in microns. Can you do that and finish with an optical surface?
Yeah, sorry, I just answered you in the chat. What we are using is infrared. Okay, so as far as I know, the correct one is green for you. So we are not able to leave a very good finishing on glass, much better finishing on steel, for example. But as far as I know, the correct one is green, or at least infrared, it is not. And that's the one that we use.
Thank you.
So it's clear the answer, but yeah, of course, we have enough people also using the green that, of course, can raise their hands and give the. But now there is another question for Raúl. So Raúl, you're bombed. So now there is Daniele from Laserpoint. You can ask the question yourself and maybe tell a bit about Laserpoint as well, right?
Yeah, thank you. Thank you, Francesca. Yes, I have a question for Raúl, because I guess that all these processes are really let's say, critical. So I guess you need to control some parameter of your laser. I wanted you to comment on which are the parameters that you eventually monitor and how you monitor it.
Okay, we can change power, we can change to frequencies, we can change the burst, the speed of the laser as well. So finally, the combination of parameters is infinite. Because there's a lot of variables, and then we have different ways of programming. So again, in combination with different possibilities in terms of programming. Then to check that all the engravings are okay, we use a confocal and focus variation microscope.
Daniele, maybe you want to mention a couple of words about...
Yes, sorry, I had a problem with my microphone. Yes, thank you very much. Yes, actually, Laserpoint, the company I work for, we are a company that manufactures laser power and energy meter, and we developed a specific instrument for controlling ultra-fast laser parameters, such as pulse energy, up to repetition rate in the order of megahertz. And we think that controlling the stability of the laser is a critical parameter in order to have, of course, an optimal process. So we might be able to help you and, of course, all colleagues in the laser manufacturing to provide a measurement system.
Sure, we also control the power of the laser, but maybe your system is with more filters than the one that we have. So if you could send me some information, we'll be more than welcome.
I will definitely.
Sounds
Thank
a
you
good
very
plan,
much.
very good plan. So we can keep going with the business. So now is Venkatramani from Fischer, who has raised hand long ago, but now is your turn. If you can unmute yourself.
My question is to Mr. Xianyao. I want to understand, how do you do this, the security check on the coins? Is it you are using some special invisible 2D codes or some special codes that can be seen only by some flashlight. Because from GFMS, we are also working with some companies who are specialized in this kind of anti-theft or anti-security kind of solutions. So if you can probably share it either offline or this one, we can work out some solutions for you.
Sure, thank you for your question. I won't be able to speak, in details for the security features, as you can, appreciate, and understanding. But we combine, at a high level, I can see we combine the laser processing to create the special, textures, and also some digital encryption technologies that, we create basically 3 defenses. So it's not just one. So, but of course, I'll reach out to you and we can talk about some of the details and see if you can help us. And really looking for, next generation, security features. Thank you.
Thank you.
So anti-counterfeiting, we will call you again, Xianyao, when we talk again about this topic that is more and more interesting for photonics. So that's very, very good to know. So now I guess we have again a question from Dimitris, exactly. So Dimitris has a question from both our 2 first speakers, and then I give the floor to Jose because YouTube is burning, and and otherwise we let it burn. Dimitris, please.
Yes, thank you, Francesca. So a question for both. Thank you for your talks. So the first one is for the Royal Canadian Mint. Do you have any idea, unless you have mentioned, I've missed it, so what kind of process speed will be acceptable to make this commercially viable, this application? So you're saying you're doing it already. What kind of process speeds you need, and what do you think you'll need in the future? And then similarly, the question goes to Raúl here. So what kind of speeds can you do now in terms of surface area coverage? And what do you think the laser technology could do, near term?
Thank you. Actually, typing the answer to your text questions. And from a circulation point of view, and currently our speed to stamp coins is 750 coins per minute. So it's kind of high speed. And if depending how you're going to scan the area, if we talk about the single coins, if we can achieve let's say 500 pieces per minute, that will be helpful at the minimum. And of course, if you do a big area, we don't have to go that high speed. But you just think about a coin, image, let's say 25 millimeter diameter. So if you can do, let's say 500 pieces per minute, that'll be very feasible for circulation coins. Of course, for connector coins, the speed is much lower because the quality is lower. So I would say the speed will be 80 pieces per minute. If we can achieve that, so that'll be feasible for our application. Thank you.
In our case, speed is not that important because we are working on die, on tool, on mold. So usually it's some hours of machine working, but of course we are not doing production. So it's our customer who is doing production with the engraving that we do in the tool, in the mold, in the die. So it is not that critical, and it depends a lot on what we have to do, of course.
Okay, so I guess, yes, I got the replies, but the one thing that I have in my mind is not clear yet. So can the laser technology right now service the application is the question, essentially. So
I think it depends on what we are speaking, because they presented a lot of different features or different ways. But for example, for die, for them, my point of view is that yes, they can serve it.
Okay. Okay, thank you.
Thanks.
And we go to the YouTube now. I can't wait anymore. It's exploding. I'm going to select 3 questions here. First, the first question is for the Royal Canadian Mint. Xianyao Li, the first question is for you. It's coming from Fraunhofer ISE in Germany. They are asking, what's the mechanical durability of the structures that you require in your coins? Because of course they need to withstand ordinary wear and tear from the wallet. Do you have some numbers of the mechanical durability specifications and challenges of your coins and medals?
Yeah, I'm trying to understand the questions about the die life.
Yes.
Like how many coins a die can survive upon striking, right? So, well, this is the interesting question. Depending upon it's for circulation coins or for connector coins. For circulation coins, the die life is actually why we are looking for like 500,000 pieces minimum for pair of dies, and that means the features on the coins need to survive 500,000 pieces or 500,000 stampings, and for the connector coins, the die life won't be that high. We talk about the 10,000, 10,000 pieces die life. That'd be sufficient for connector coins. I hope that's the answer my friend at the Institute is looking for.
The group of Andreas Branding from Fraunhofer ISE, they actually have analyzed lots of different coins and they have some understanding of what kind of surface damage they can withstand. So I think offline you should have a discussion. The second question is going to Microrelleus. It's coming from California and going to Barcelona. George Wilkes, who is the CEO and president of QPC Fiber Optic, is wondering, can you share with us a few numbers of the feature pitch for super hydrophobic structures?
We're usually working in the range of 20 microns. So it's 20 micron pitch, 20 micron depth, more or less.
And I stay with you in Barcelona and I go from California to Israel. Reputable and renowned consultant Yuval Ophir has also a question for you. Can you make black glass by microstructuring?
We never did it before. And I am not really sure about it because there is better wavelength for glass with more quality. And I think it is required for this kind of application.
Thank you very much, Raúl, and thank you all. What a fantastic Q&A, Francesca. It was really, truly fantastic. Let's move on with this fantastic program that we have today. I said already the laser micromachining event of the year. Now we go to the second part of this meeting, and we're going to start with Andrew Honegger, the Vice President owner of Nano Illusion, part of George Fischer, and we'll continue with the CEO of Workshop of Photonics, Martynas Mažeika. First, Andrew Honegger, thank you very much for being with us. Tell us how we can help you, because this meeting is about helping. The floor and the attention of everyone goes to you, Andrew.
Yeah, hello, everyone. My name is Andrew Honegger. I am the head of R&D for Microrelleus, and Microrelleus is a part of Georg Fischer Machining Solutions. So today I'll talk about what we offer and what we do. So Microrelleus is based in Chicago, and we specialize in making high precision laser workstations with an emphasis on using ultra short pulse lasers. So we talked earlier about, some of the presenters talked about pico and femtosecond lasers. So we're using those quite often in our workstations. Also, we focus on very high feature repeatability and also part positioning accuracy. And the third thing we really specialize in is providing our customers a turnkey solution. Typically for producing parts. So you can see some examples in these pictures. We have in this lower left image, this is an example of something like a diesel engine fuel injector nozzle. You can see that there's some tiny black dots, and those are the holes, the fuel spray holes for the nozzle. And up in this upper right picture, you can see some examples of fine cutting that we do. And these are examples of Swiss watch parts. So in general, we serve quite a few markets. They're listed here. One example is fine watch parts. Also, we do a lot of spray holes for various types of fuel injectors, gas, diesel, other types of fluids, medical parts, ICT, electronics, making very tiny round or even sometimes square or rectangular holes, and for electronics applications, and also for aerospace. What we offer, we have several machine platforms that we offer our technology on. The most flexible or the most widely used of these platforms is called the ML5, which you can see in the left picture. This is a highly flexible platform. It's available in 3-axis configuration or 5-axis configuration. And in this platform, we offer a beam delivery system that enables taper control of the features. So anything from positive taper to straight wall to even negative taper. In the middle, we offer a somewhat larger machine. This is the ML10, which is primarily targeted toward the aerospace industry. It's a 5-axis motion platform as well. And it's really geared toward enabling not only the ultra short pulse lasers that we typically use, but also some higher powered lasers that are necessary for this industry. And on the third example of machine platform that we offer is called the MLTC. This is a machine that's specialized for cutting tubes, mostly used in the medical market, cutting tubes of various types of metals or even polymers. And one of the specialties of this machine is that we can cut very, very small tubes down to even 1/4 of a millimeter in diameter. What we look for, this is kind of what we look for in terms of the applications that are good fits for our machines. So in general, there's really 3 types of features, 3 categories of features that are really well suited to our machine. So one is hole drilling. And these types of holes that we can drill are can be very, very small, down to 20 microns in size, or can be somewhat larger, up to several millimeters in diameter. And depth wise, with the laser, you can achieve a 6:1 aspect ratio is, we'll say, very easy, and 10:1 aspect ratio is still achievable in most cases. The second feature type that we often use is very good application for us is fine cutting. So things like in this upper left picture, this is something like a marker band part for medical. You can see the fine cut edges on either side, or in the right picture, this is something like a stent for medical industry. You can see the very fine cuts of that feature. So cutting profiles with very high profile accuracy, very high surface finish, and also very good control of the taper of the surface is really what we specialize in. And then the third feature type is 3D features. So in the middle picture, you can see some diffuser shapes in an aerospace part. And so these are often 3D, small, relatively small, on the order of a few millimeters in size, cavities that we machine using scanning with the laser. And all of the features, or let's say many of the applications that we come across, no matter what feature type it is, they have several key characteristics that really make it a good fit for our technology. One is that we're really looking for high quality features. So ones that need no heat affected zone, very high edge quality, high repeatability of features, for example, in spray applications needing very stable flow rates part to part. Accurate positioning, this is where our machine technology really thrives, providing ability to measure parts coming into the machine and locate features accurately to those incoming features. And also having a machine platform that is very stable and very repeatable and very accurate. And often the types of applications that we come across also have a defined taper. So again, this is for spray applications, often to achieve a particular spray characteristic, it's important to have either zero taper or maybe negative taper or maybe positive taper features. So thank you everyone for the time. I'll be happy to answer any questions you have.
Thank you very much for that. This is only half of the story. This meeting is about matching. We heard the workstation from GF Machining looking for partnerships. So we're gonna go to one of the key companies we have in EPIC on the glass and other materials services providing and workstation providing. We go to Lithuania, go to Vilnius workshop of Photonics. Martynas, the floor and the attention of everyone goes to you.
Hi. Can you see the screen okay?
Crystal clear.
All right, so thank you for your time. My name is Martynas, I'm the CEO of Workshop of Photonics. And the things that I want to present today, I think will be very applicable to a lot of you. What we do is we, as I like to talk to my friends, we shoot lasers at material and see what happens. And that means that we provide solutions for your micro tasks. We have a total of 18 years of expertise now in this field, and we run around 400 different projects a year in terms of applying femtosecond lasers to different materials and seeing what we can achieve. So first questions we usually get from the clients is that, is it possible? And this is what we're happy to do. We have a lab currently with 11 different laser sources, 5-axis scanners, normal scanners, very fast scanners, positioning stages, in all kinds of axes. And we will investigate your task and deliver prototype to test in the real environment. This is mostly meant for people who either didn't see a laser in reality at any point of their life, but are very interested in to see the possibilities, or people who reached the limit in some way on what they want to achieve in terms of micro machining. And here we see that we can provide a lot of answers in terms of all kinds of materials, including glass, sapphire, ceramics, metal, plastics, optical fibers, you name it. And then we can scale it as we do production services in-house. That means that we can deliver small or medium scale production of set samples or manufacture units to your liking. And we see that also a lot of clients make use of this because especially in small batches, we see that it's not feasible to yet get a laser system. And we think that laser micromachining in this case would be a very good answer, because in this way you don't need to manufacture any kind of molds or masks as you would for different technical approaches like lithography and similar, which allows fairly competitive price range for even small scale production. We concentrate on glass, sapphire, and other brittle materials, but I will talk about this a little bit later. And then usually in this full service solution, the client comes to a point where they want to have the tool in-house. Then we will develop a laser workstation to your specific application and transfer with the recipe. So in this case, we help the people with the question, so what if the tool that we buy will not deliver what we need? And what if the company that we approach with the production will not be able to transfer the knowledge to another integrator who should build the tool? So in this case, because we do all three, we can provide the client with the full service solution. And we see a number of customers in a couple of years time run through all three of these and are now happy users of their own laser systems and come to us with different kinds of challenges. Because as previous speakers mentioned a little bit, laser is a very flexible tool if you know how to use it. And there's different wavelengths, different energies, different scanners, different positioning systems. And usually for people who are not heavily involved in an integration of different system components, is difficult to choose and difficult to find the right answer. So this is where I think we can help. In terms of technologies, we have several proprietary technologies that should be interesting to a lot of you here in the audience. We have glass dicing and sapphire dicing solutions, which are for glass thicknesses of from 30 microns to around now 3 millimeters went. For tempered, non-tempered glass and sapphire, cutting speeds are usually very high and competitive to anything in the market. Any shapes are possible, and there's almost never any chipping. That means that we can create, well, for some examples, let's say here you can see on the pictures, you can see cover glass, which we can create thousands in a matter of hours, or give you what we call femtofab or femtoglass machine, which can do this in-house. And we're actually talking with a couple of potential customers here in the audience for this already. So this is for what we call outer features, outer cuts of the material. For inner cut of the material, we have glass drilling. And here we have a question on how many holes can you drill in glass per 1 minute? And in the market, we've seen 1, we see 10, we see even 100 with some methods. We have a current benchmark, which is 50,000 holes in a minute of hole diameter of around 30 microns on a 500 thick fused silica wafer. And we don't think that anybody could beat this, but maybe there's somebody in the audience that can challenge me on this. So we create all kinds of features inside of glass and fused silica. They start from 20 microns and can go up to anything 400 microns, 800 microns, 1 millimeter or more. It doesn't really matter that much. Hole size tolerance is up to 1 micron, and aspect ratio also can be from 1 to 100. That means that we can create very small features in very thick glass. So these two technologies, this is why Jose mentioned glass, these two technologies I think puts up very high on the application level and how we can solve problems for you. So several examples that we have here from the 400 that we do a year, just some that I think would be interesting. One application that we had is microfluidic chip bonding, where we have 5 layers of glass micro machine and then bonded together to create without adhesive to create a layered microfluidic chip. So this is all laser machined and laser welded and then on the one station. And then we also see that sometimes it's feasible and even beneficial to the customer to switch ceramics or other materials to glass. And one specific example for guide plate manufacturing, so these are guide plates for probe cards. One of our customers switched ceramics to glass completely. He sees 80% less defects and 20 times faster processing in terms of how you machine this. Third project that I'm showcasing is metal needle micro machining. So this is just to showcase our ability to work on fibers, capillaries, and needles. That might be from metal. It can be from, in this case, it's tungsten, but can be also from glass or any other kind of material, where we can shape, cut, or drill the fibers or capillaries to any kind of shape. So this shows tip diameter of 5 microns on a needle for a neurological application, I believe. And currently I counted 14 of our customers here in the audience. The rest, I have a message also, don't hesitate, contact us with your micro challenges, and I'm sure that we will be able to help. We concentrate on markets which deal a lot with glass and other brittle materials, so a lot of companies from electronics or biotech approaches. And also what we need from you, so we partner with a lot of companies in photonics field in terms of running their equipment through their bases. I might say, right? Because all these 400 tasks that we get, they come directly from the final customers, and they have real life applications. That means that we can test out lasers, we can test out positioning stages, we can test out scanners, and all of them together to see what kind of final result we might have. And we saw in the past and currently we see a lot of very interesting new micro machining technologies being developed, and I mean in terms of equipment which can improve. Because what we like to do is because we build our own workstations, we always try to test out new things and see which equipment could give us a sharper edge, I would say, maybe to perform even better and to show better results to the customer. So that's it from my side. Thank you.
Thanks a lot, Martynas, and thanks a lot, Andrew. So we are talking about micro challenges that can be huge challenges, right? Because micro is just the size, but no. So thanks a lot for your contribution. So from you, I will be a bit more, let's say, chasing you, because you are a machine builder, also service provider. So we want to actually hear the answer to the epic questions. What can you do for them? And this you answered both very well. But what they can do for you? So the people in this room. So we start with Andrew again. So we heard already in the chat, there are a lot going on about which laser do you need? I need this 100 femtoseconds. But what about your lasers, for example?
So at Microlution, we use, other, obviously we don't make the lasers ourselves. We do have standard lasers that we put into our machine, which are femtosecond lasers down to, let's say 300 femtoseconds up to a few picoseconds is sort of the normal range. But in general, over the course of time have integrated lasers that meet specific application needs. So especially with femtosecond lasers over the past 10 years, I mean, there's been a dramatic improvement in average power, industrialization, improvement in the features available within the lasers. So as time goes on, we adapt our technology portfolio to sort of meet the available technology and the application needs.
Very good. And I guess in the room, we have someone, the one who's asking about this also to General Atomics and also to everybody is Aldas from EKSPLA, right? Aldas, maybe you can tell us what is that you can offer.
Sure, Francesca, thanks a lot. So I just make very briefly my suggestion to everyone to the laser integrators. It's our new product, Fluence 30, is a femtosecond laser of 30 watt average power. And the difference comparing with others of similar power is that we use a different approach of laser cooling. Instead of using water, as typically those power lasers are being cooled by water, we decided to use a direct refrigerant cooling method while cooling the laser through the detachable cooling plate. So instead of water, we use a direct refrigerant, which means there is no risk for damaging neither laser nor any other equipment in the case of unfortunate leakage. And of course, there is no any additional maintenance is required for chiller as for the particle filter replacement or for the water replacement or system rinsing. So, and of course, entire system, because of no additional components, are lightweight. So entire laser system contains only of 2 units, laser head and power supply unit with integrated cooling system inside, and no any additional chiller, which is heavy and bulky typically, is not required. Laser parameters is as I mentioned, 30 watt, more than 90 microjoules of pulse energy, very high repetition rate of up to 4 megahertz, which is controllable by the pulse picker, and of course integrated attenuator and other parameters are of the highest level. So what we are looking for laser integrators who would be willing to test our laser with their equipment. And what I forgot to mention, we are very highly flexible in terms of customization for each and every application. So please feel free to contact me if you are interested.
Very good, Aldas.
Our laser.
Thanks a lot. Thanks a lot for this jumping in. So this is the offer. EKSPLA is there and EKSPLA wants to help you. But now let me go back. Thank you. Let me go back to Martynas again. So let's to the ball, so to the court of Martynas again. So I have a question already from Dirk from Coherent, right? So let's connect this question. Maybe Dirk, you can ask it loud, and then Martynas can comment a bit on his needs also.
Yes, I'm very interested in the application of drilling holes in glass with the high aspect ratio. And I've seen some similar applications before where it was done with a combination of light illumination and then differential etching. So I wanted to ask if your process is also relying on a second step, or is it purely ablative?
No, it's not purely ablated, of course. So in this case, we also have a similar method which involves chemical etching afterwards. So we won't call it maybe light illumination as you would call it, but I think in principle, what you're asking is it has an additional step in terms of chemical etching, yes.
So you need some chemical to then actually etch the holes.
Yeah, yeah.
Got it. Thank you.
So very good. Now I go back to those who have questions, who have the raised hand. So talking about glass, I would go, please allow me first to Emmanuel from Biomimetic, because I bet he wants to tell us a bit of the interesting things they are doing, right?
Sure. Shall I present?
Yes, if you have questions, please. Otherwise, if you can tell us a bit what Biomimetic is doing.
I have a question, and also I would like to present you
a
single slide about Biomimetic. So, can you see my screen? Yes, I hope.
Yes, all good.
So we are working on laser nanotextured glass. So these are two of our products. The anti-glare glass product that is coined as Statics AG and possess remarkable combination of anti-reflection and anti-glare property. And also the Statics AF, it is nanotextured glass that shows remarkable anti-fogging properties that are, let's say, suitable for applications in humid applications. And our motto is nature's ingenuity on surface engineering. And I would like to ask the workshop of Photonics how they told us about the advantages of the process, the performance of the process. What are exactly the most critical limitations that you are facing in order to reach higher performance as far as the processing itself and also the possible, let's say, defects on glass that limits the performance of the cutting process?
So I can answer the question regarding the glass cutting. On glass cutting, we mostly work in infrared. Can also work in green, but mostly infrared. So coatings is a challenge that we always have to solve and usually successfully solve, but you have to adhere to that on terms of what you have on the surface. Limitations in terms of microstructuring, I would say for us is understanding of the glass itself and the chemical properties, because there is glass and then there's glass. Only when I joined the company, I realized that there's like 3,000 different glasses out there and all of them are different. So we spend a lot of time, doing different things on different materials. All of them are a little bit different.
Okay, we know all the glasses are, there are many glasses. Something more specific that you can comment on what kind of property they would like to improve on glass?
Well, you're probably going towards clarity, right? So yeah, of course, you know, if because we shine light through glass, if it's not clear enough, it's a problem.
Okay, thank you.
Okay, very good. So now let's go back to Xianyao. That had you are muted. Now
hi,
you can
yeah, thank you. I have a question for Andrew. You have talking about fine cutting. My question is how thick and what speed the cutting would achieve. For example, if I have 3 millimeter thickness of silver plate, how quickly you can cut, and are you able to cut, you know, the 3 millimeter silver plate?
There's a variety of factors that come into play there. Thickness, the desired quality in the end, the requirements of the edge in the end, all of those come into play. But just to give a very broad number, I would say, you know, typically in that range, it's probably below 10 millimeters a minute, maybe 5 to 10 millimeters a minute. So it's fairly slow, I would say. You know, most femtosecond laser machining at a relative scale is fairly slow, but it achieves, you know, a high quality.
Good, thank you. I'll probably contact you, maybe send you some samples.
Oh
okay,
yeah.
yeah,
This is the magic word. Sending some samples. Oh my God. That's a very good proposition. So that's what always we ask our end user and anyway integrators to do with our audience. Very good. So now it's time for Mark, UPMT. Do you still remember your question?
Yes.
Sorry, you have the hand raised since long.
Yes. Yes.
Thank you.
Exactly. So I have just a question about the materials and you're speaking a lot about metals and glass, but in fact I would be interested to know if you have experience in cutting or let's say dicing of plastic materials, polymers, optical polymers, thicknesses about 1 millimeter. Do you have experience using laser as an alternative solution to diamond disc dicing? And can you tell a bit about aspect ratios that can be reached, the cleanliness, deformation, things like that? So either Andrew or Martynas. Yeah, sorry.
Yeah, I can answer first. So we do have experience with polymers. You mentioned optical polymers, so we don't have as much experience with optical requirements. Typically, for many polymers, a green wavelength laser is helpful. It's not always required, but often helpful. But I guess, direct experience in what you're asking, I would say we don't have a whole lot. We have, some maybe more tangential experience.
Okay, thank you.
Okay, I can
sure
answer the
Martynas.
question with the screen maybe. To show some examples, just so this shows plastic. We do cutting and drilling. So this also shows plastic, and thin film cutting is also here. So about the cleanliness, and I think you can have some idea. And I think for more we need to contact afterwards to discuss the materials. But yes, we have experience in cutting and drilling plastic for a lot of biotech microfluidics applications where they need layers of plastic in very fine features. Some other applications as well.
Okay, thank you.
Very good, thanks a lot. Now, I wanted to maybe just give the word, because if you are in YouTube or you will watch this later on, you don't know what, there is a lot of going on in our chat about General Atomics. So there is Andrew in the room that talked already before, and maybe can introduce himself and say, what are your needs, what you are doing, and why you have connection here and you're interested in this meeting, and hopefully also for the future for us, we can support you further.
Yeah, hi, can you hear me?
Yes.
So Well, at General Atomics, what I do is a lot of fine micromachining, and we have various interests in supplying exotic materials to the fusion research program in the United States. So I've done things such as drilling 5-micron holes through beryllium shells that are, holes might be 200 microns deep. I've also dabbled in diesel injectors and worked with backhaul protection for some time. And more recently, I've been interested in processing difficult materials such as magnesium oxide glass, and I also process beryllium and depleted uranium to shape them and contour them. And typically we're after good surface finishes and micron level control of various surface features that can range from simple to fairly complicated.
Very good. So it's a good overview, at least about your experience and also in your chatting in the chat. So there were some questions to you. I hope you were answering at least to them. If there's something we want to bring here in the room, please feel free to do it. But now I maybe give the floor first to Christian from Optocraft, who has still the hand on, and then I go to Dimitris. I didn't forget.
Yeah, thank you. I'm just responding to Martynas, who asked a question about what the companies from the audience can do for him in order to improve the laser systems, basically. So Optocraft manufactures and develops Jacquard-Hartmann wavefront sensors, and that is one option to that will help you. Basically, all manufacturers of femtosecond lasers and of laser systems with advanced optics inside. So you can use a Jacquard-Hartmann wavefront sensor to align these optics and also to in the end measure the quality of the laser. So it's a quite interesting alternative to an M-square measurement using a Jacquard-Hartmann wavefront sensor, because it's quite simple and fast. So you have just one shot and you get information on phase and intensity from your optical system. And also it's in real time, so you can really use it, the wavefront to do alignment tasks. So basically to have a wavefront sensor in the lab and to use it to improve your optical layouts of your laser systems, that's really helpful. And I'm sure several of you laser manufacturers here already are using Jacquard-Hartmann wavefront sensors. But if you do not, talk to us. And there is also another application that I think is interesting, and that's we are just getting in touch with this more recently is the active alignment and the control of such systems and machines like Andrew Honegger showed. There are actually companies who are thinking about integrating wavefront sensors into such machines in order to control the machine and the beam quality. Yeah.
Very good. So if they forget to reach you anyway, Christian, Optocraft, ask us. Otherwise, that's the right address. Thank you. So now finally, there is a question for Martynas still, from Dimitris. So you can ask it, then we go on with the agenda.
Okay, thank you. Yeah, thanks very much, Francesca. So a very quick question for Martynas. Very impressive presentation, drilling these high density holes for probe cards with glass. What I was going to ask you, and possibly you've answered that, is do you encounter any cracking when you do this high density work? I suppose you partly answered because you said you have some chemical etching step. So I understand now it's not an ablative process, but it's selective laser etching. And then that leads to the next question. This is a very low power used normally for selective laser etching. You don't need a lot of, it's not a hungry process. So do you actually use parallel beam processing? Do you split your beam and drill, I don't know, 100 holes simultaneously to get to this 50,000 holes?
No. So the benchmark that we have is one laser. No beam splitting. Okay. We were looking at beam splitting in terms of it is possible to do, but you need certain pitch and certain design. So this was achieved with single. Of course, we can go higher, but we see that takt time then depends a lot on chemical etching again. Laser processing is faster than chemical etching in any way.
Sure. Okay.
Very good.
Okay.
So then I guess it's time for the next couple. The couple, the epic couple. So the next one, they are together because we think they have a very good feeling for R&D. So one is our workstation builder, and you have it here. He has already the floor. Is Dimitris from Oxford Lasers. But we have also a new entrepreneur that after the experience, well, and still experience at Fraunhofer IWS, is now funded a new company called Fusion Bionic, dealing also with surface structuring that we heard before. But now let's start first with Dimitris and Oxford Lasers. The floor is yours.
Okay, thank you. I'll just share my screen. And we should be able to go in a minute. Okay. So hopefully you will see this now. So yes, excellent, thank you. So my name is Dimitris Karnakis. So I'm just the R&D manager at Oxford Lasers, responsible for collaborative research and technology development. And I've been with Oxford Lasers for 18 years. So before that, I was in academia and research in Japan, and I started from the University of Crete, where my knowledge is, and spoke earlier on. So I'm just going to present to you Oxford Lasers to start with, so that you understand who we are. So we're a laser micromachining solutions provider. So we started as a spin out of the Oxford University back in 1977, one of those really historic companies actually in photonics, and initially building lasers, Eksma lasers and copper vapor lasers. And then from probably the middle of 90s, we started concentrating on industrial laser micromachining as well as high-speed imaging. We offer two things, which is laser products and laser services. And nowadays we have 65 people, all of them highly specialized, or most of them very highly specialized, and based in two sites. One is in Didcot, just south of Oxford in the UK, and one is in Boston. We have installed a very large number of systems and lasers in 27 countries, over the last 43, 44 years. And we are predominantly active in the semiconductor market and microelectronics, less in automotive nowadays, but more gradually in aerospace, pharmaceutical, microengineering, and do a lot of bespoke systems for research and technology organizations. The key to our success is, of course, that we continuously invest and innovate in order to survive, which I'm sure all of you know very well is needed. So the first question that I have to answer is, what can we do for people here? And of course, we can do two things. One is we can look at you as customers. And the first point there, it says that since we are a micromachining solution provider, if we have any customers here in the audience, the first thing that we do is we actually work with you in feasibility studies to prove certain concepts. So I think others have mentioned already, laser micromachining is not a simple business. So you have to actually invest some time to develop processes. So those particular laser recipes, which then we can use, if they're successful, to actually run part production in the low volume, middle level volume, up to a price point that is okay for our customers. And then if that exceeds a certain threshold and the customer thinks this process is too expensive, then of course we can design customized laser micromachining systems, which we're installing to our customers, training them how to use them. We're sharing the recipes, the laser recipes. And of course we have service units that fly around the world all the time to actually service those systems. So the important thing here is that we are very confident that we can process virtually, I'm saying here, any material. We're doing thousands of jobs per year. So we have lots of experience basically in processing different materials. And of course, if you're not a customer and if you're a part of the supply chain, we can work with you to integrate your products and your equipment into our systems. We are at the top of the pyramid providing the service and systems. So we like to talk to people that have innovative products. The other thing that's really important here, the fourth point, is that we normally participate in collaborative research. And now with Brexit finished and all that being put to bed, we are also going to be active again back into Horizon programs. But also we participate in UK programs and transnational programs as well. So we would like to talk to you if you have any ideas, and we find some overlap there. So that's dealing with what we can do for other people. In terms of what we do, so that you get a better understanding here. So of course, I said already, we just make systems and we actually provide services. So I should start by saying we are probably one of the first points of call for micro drilling. We have a lot of expertise, you know, more than 30 years probably doing this kind of thing. We can drill any type of hole, any shape, 3D shape. You know, I've heard earlier on tapered holes. We can do zero taper holes, positive, negative, squares, round. You know, we're doing millions and millions of holes per month, I should say here, if not per week. We also work with all different types of materials, like others have mentioned here, metal, ceramics, glasses, polymers. We do micro cutting, we do micro milling, surface structuring, which was mentioned earlier on, so you see some examples here. A lot of work on thin film patterning. We've done a lot of collaborations over the years. We have developed specific recipes for specific materials, you know, very, very ultra thin materials down to 20 nanometers. And of course, a newer process that we're doing, which is only active on this thing for 4 or 5 years now, is glass micro welding using ultra fast lasers, not for only glass to glass welding, which I've heard earlier on for hermetic sealing, but also glass to metal, which is a much more difficult kind of situation here because of the different thermal expansion of the materials. But we're very successful on this front, and we are providing solutions for precise welding of mostly optical components for photonics, aerospace, and other industries, and also hermetic sealing. So in terms of our products, I mean, we do a lot of different kind of products, all of them based on 4 platforms. They're all turnkey laser systems, which are customized starting from those platforms, choosing the correct lasers, choosing the correct beam delivery and diagnostics together with the customers, basically, and then designing around those platforms and providing those systems. So you can find a lot more information about what I've just said on systems and services on the website at oxfordlasers.com. So I'll just finish off with the slide. So what can you do for us? And so it's a little bit you like more generic stuff to what people have asked before. But in terms of lasers, so there's 2 categories basically. In terms of the technical things that we want to see, in terms of lasers, which is the heart of what we do here, and we're talking DPSS lasers, we would like lasers with better dynamic performance. That's the one thing that seems to be critical if you're operating at the precision end, and also you're trying to achieve high process speeds. So we don't want the laser properties to vary if we just change, you know, if we dial one knob, we don't want the parameters to actually change significantly. The other thing that seems to be a gap in the market right now is deep UV lasers. A lot of people have tried to enter into this, but there seems to be some issues with deep UV lasers. I'm talking 266, you know, 4th, 5th, even 6th harmonics now people are discussing, and then lowering the cost of lasers, which is always an issue. The second point is, and it is a key thing here, tailored beam delivery is key. I think we want beam shaping, special temporal beam shaping, and also we would like to see, to hear from people that build equipment for precision, you know, 5-axis processing. This is key for next generation machines. Very important point number 3 here is, we get all these lasers that gives us hundreds of watts of output power, but what can I do with 100 of watts of laser power? So anybody that has ideas and willing to share how you utilize this high laser power for micromachining, please talk to us. And similarly, in the same vein, anybody that has activity in AI for laser micromachining, I think this is definitely going to be the future. We want to be able to find solutions very quickly for our customers, and AI probably is going to bring a lot of solutions here for us. We're already active in this field, but we want more and more people to talk to us on that. Now, in terms of business or other issues, if you like, Marcoms is quite important, and EPIC is doing a fantastic job here. We can't stop commending them. Yeah, thank you for that. So market research, market intelligence, promoting the entire laser technology field to other industries, very, very important. You know, we're all on the same boat here. So we need more of that. If any academics are in the audience, skills and knowledge obviously is important, underpinning everything we do. We want to be employing people that they're skilled and they have the knowledge that we need, and employ people that have ideally exposure to all of those skills and knowledges that they're very useful for laser micromachining, so they can actually help. And again, back to the same point I mentioned earlier on, we are open for collaborations at the European level or local level here in the UK or transnational. So if you have any ideas, please come and talk to us. Okay, so I'll just finish with that and I'll put my website there. So, okay, thank you very much.
Thanks a lot. So that was the best slide, you know, that we always like this slide. So we will keep it in mind now, because first we give the floor to Tim Kunze from Fusion Bionic, our new spin-off that we talk about today. So Tim, are you there?
Yes.
The floor is now yours.
Okay, let me check. I share the right screen. Okay, do you see the presentation?
Yes.
Okay, so Francesca, so thank you very much for the introduction. So as already introduced by Francesca, so we are, let's say, a very young company. So we are a spin-off from the Fraunhofer Institute of Material and Beam Research or Technology, funded actually last month in April. And we are, let's say, commercializing our core technology, which we developed over many, many years based on interference. And of course, let's start with a short introduction. Let's say our motivation, let's say, comes definitely from poor surfaces and surface performance, where we, let's say, can offer here a very, let's say, unique and new technology based on interference principle to, let's say, introduce laser surface functionalization approaches as an alternative to coatings or even an add-on. And let's say, I mean, probably known to all the participants in the audience. So of course, laser is a nice tool for non-contact processing. This all applies also here. And we take use, for instance, like also biomimetic from, which, let's say, was also, so Emmanuel was talking about that. So we, let's say, use laser-generated micro nano textures, let's say, to advance products, to introduce, let's say, new functional surfaces by our approaches. And let's say, talk a little bit about the core technology which we have in the back is, let's say, called direct laser interference patterning. And some of you know that we are active in this field for many years. And let's say now are ready to, let's say, commercialize this kind of technology in compact and versatile laser solutions. And which in principle is also applicable to almost any technical surfaces and any shape. And of course, this is, let's say, a big plus where we think it's on the technology side is also you can use what Dimitris has already said, let's say, a high laser power and distribute this energy, let's say, very nicely across the surface and take really advantage of the growing, let's say, power of the laser sources. And on the right-hand side, you just see this image that we that in a very nicely way overlap, let's say, the sub-beams of a pulsed laser source, which actually creates some interference pattern, so with some modulation within the beam. And this, let's say, is used for structuring. And as already, let's say, shown in the last year, so I had also the pleasure, let's say, to give some talk there. You can also now, let's say, imprint this kind of pattern. So it could be, let's say, different shape. You can imprint these patterns on materials. So it can be metals, it can be polymers, it can be glass, like also raised by Andrew, for instance, and even coatings to advance, let's say, to have an optimized engineering of the surface properties. So we have a very, let's say, tremendous, let's say, possibilities in surface texture design. And of course, this opens up a lot of possibilities in a lot of application fields, like shown here. And where I would like to just highlight all the possibilities which you have and which we also have in mind. Let's say we have shown, for instance, that this kind of approach using the interference, let's say, technology, you can, for instance, create anti-icing surfaces, which, let's see, where ice, for instance, cannot stick so nicely. And also you can increase the efficiency for the de-icing. You can, let's say, in the automotive area, let's say, work on optimized electrical connectors to reduce electrical resistance. You can address, let's say, the topic product protection, which was, for instance, shown by the Royal Canadian Mint, so Xianyao. So it's also a lot of potential here, I guess, also for decoration. So in principle, it's a lot of possibilities, and we are quite happy, let's say, to go in this direction and use the solutions which we can offer. So are in principle on in the core, let's say, compact modules like shown on the left hand side, which is to our knowledge, let's say, a world novelty. And of course, let's say, offer this for later integration or even on, let's say, own micromachining solutions. So in principle, they come with different wavelengths, different feature sizes. So this, let's say, we are quite open to talk on this later on. And of course, let's see what can be addressed with that is, let's see, different application examples like shown on the right-hand side. So as already said, for decoration, so you can really play, let's say, with this kind of textures in such a way that you can really do a color engineering, and also do light guiding. Wettability was what was also shown by Raúl, and also controlled matting. And this was also, I think, questioned, or there was a request from the YouTube channel. So for instance, a matting of glass, so blackening of glass is also, for instance, something which we have done. So we have experience here, and potentially, if there is some interest in collaboration, then we are really looking forward to some discussion, and hopefully we can provide some solution. And of course, the very famous, let's say, final slide of the talk is shown here. So what we can do for you is, of course, we are a solution provider for DLRP technology. Of course, have lots of years, many years of experience in the field of different materials, different functionalities, can do the process development, and also the engineering service, which means, let's say, also the buildup of, let's say, new prototypical system, which we also, for instance, have done very recently for electrical connector functionalization for a very big automotive connectivity supplier, and also do integration, service support, and training. And what you can do for us, of course, is we are quite interested in new applications. So we would be really happy to be involved into your surface engineering challenge. And this is, I think, a big plus that we have, of course, some R&D background. So we know, let's say, how to address challenges in this field. And of course, maybe from the machine side, or let's say the laser side, there's also a request from our side that, and this is a property which is usually not so, let's say, quantified, is of course the coherence properties of laser sources. Yeah. So in our let's say case, we rely on coherence of the laser source, which, let's say, makes the interference pattern possible. And we are really looking forward to know more about your laser source. Is it suitable? So we know a lot of laser sources which are already, let's say, possible or suitable, but we of course would be interested to learn more. And of course, as also said by Dimitris, we are also interested in partnerships and collaborations in R&D and other kinds of collaboration. This is something where we are really looking forward with you.
Thank you very much, team, for a great presentation, and congratulations on this development. We heard from Dimitris, the key company in EPIC on laser workstations looking for partnerships, and then we heard from Team Cons with this fusion bionic surface personalization new development. Lots of room for cooperation here. Let me start with Dimitris from Oxford Lasers. You actually had a challenge, very clear challenge when it comes to the deep UV laser. Dimitris, I also noticed that gap in the supply chain, but I believe that there is a potential collaboration with light conversion. Martynas, what's on your mind?
Hello, Dimitris. Long time no see. So my question was, when you speak about the deep UV lasers, can you elaborate a little bit more on the parameters? And of course, at least on minimal parameters, right? Minimal usable parameters.
Yeah, so I don't have hard numbers to give you right now, but I mean, what I would say is that everything is driven by cost here. So the majority of glass and polymer processing that is done right now ends up being transferred to ultra-fast lasers because there's no really good deep UV DPSS lasers out there if you want to avoid the eczemas. So if you have an application that cannot carry the cost of an ultra-fast system, and unfortunately light conversion is in this category in this case, but you need a very low value nanosecond, as you have said there in the slide, deep UV, which can actually be absorbed really nicely in polymers and glasses and do fine features essentially. So we're talking things that they are, you know, at the 10,000 level source cost rather than much higher. So it's probably outside the brackets for the ultra-fast lasers, but there is a gap in the market there.
Definitely there is. And a challenge for the EPIC community. If you have developed a deep UV laser source and you're looking for the right system integrator, Oxford Laser is the right company for you. Dimitris, in addition, you talk about beam shaping, which is a hot topic for us. We organize already so many meetings on beam shaping. We have lots of companies in the room. But I am very interested in the applicability of the micro optics. We are living the second micro optics revolution in Europe. I think we have Wilfred Null, the CTO of SUS Micro Optics in the room. Wilfred, are you with us? All the way from beautiful Neuchâtel in Switzerland.
Yes, I'm right here. Can you see
me? I have here one of our key system integrators in EPIC, workstation manufacturer of Oxford Laser. Is there anything we can do together in terms of beam shaping?
Well, yes. I mean, we've been doing beam shaping since 20 years, basically, since the beginning. So for diffractive and refractive optics, could I share a slide or two?
Yeah, show me some pictures. I love the visual explanations from Wilfred.
So let me see if that works. You see them?
Yes.
Okay. So here we do beam shaping optics, like I said, this since the beginning of our existence. So this is why we were actually established to make micro optics for all types of beam shaping. And you see we can do here flat tops, line generators, spot generators, and also 1D lines. And this is all good for, I mean, I'm preaching to the the choir here. So this is all good for all types of ablation applications. So we can also do Gaussian beam shapes. So the source is always a bad M² laser or some type of laser, and then we have to shape it into whatever shape we do. So we offer refractive optics and diffractive optics in this and especially what you see on the bottom left here, this is most of these are for deep UV applications. So it was mentioned before, deep UV is coming. So Eksma lasers have been around for many years. So we do a lot of beam shaping optics for Eksma lasers. You see, we can do that with a very high precision. And yeah, so if anybody needs beam shaping, or we can also help with the design there, the optics design, obviously, this is essential to know how to do this. We can help you.
Well, Dimitris, challenge us. We love challenges. Are you looking for a flat top? Are you looking for a line? Are you looking for the perfect Gaussian?
I was just going to say, so I mean, we have trialed a lot of different suppliers here for beam shaping. So the challenge is, how close can you give me a really nice, for instance, top hat beam, but close to diffraction limit? So I know there's fundamental limitation from physics, I guess.
Beam shaping and diffraction limit are two words, they don't like each other. So,
exactly. I know that.
To do beam shaping, you have to add angles, and as soon as you change angles, you have an extended source basically, and you can't be diffraction limited anymore in your spot size. So you can have you can superimpose like 3x3 spots, so you are almost diffraction limited and already have a good beam homogenization. So this is basically a spot generator. So this is something that is feasible and that we design and manufacture.
Yeah, so that's one thing, because precision is moving forward. So, you know, everybody's going to smaller and smaller sizes. So if you want to control better, you know, what's happening at that small scale, and you need a homogenized beam, we need somehow a solution for this. The second thing that's really important is how configurable are all these beam delivery arrangements. So with diffractive optics, you're somehow fixed. There's other methods that they're more configurable. That is, you know, where we would like to see developments there, basically. So, and then configurable, for instance, special light modulators, they're good, but they're only good for certain wavelengths. They can't do UV. So there's all sorts of things that we can actually work on. If there was technology solutions out there, they're definitely needed. If you have the solutions, come and find us. That's definitely what I would say.
Right on the money, Dimitris. One question in YouTube exactly about this. They are as amazed as I am for your zero taper holes. And they are asking you if you can share, to some extent, your secret. How do you manage to achieve those zero taper holes? Of course, answer to whatever you want. If it's multi-axis, if it's been shaping, just give us some meat to work.
We're very careful how we use our equipment, and then we drill those nice holes. So
I think that's a good answer. Don't say more than that. Yeah. And I want to go also to fusion dynamic. We really love what you do, and we love when people bring the nature concept to the real photonics manufacturing. We have a few questions for you, but the first one is coming from Italy. It's coming from OPTOMAN. Giuseppe D'Amelio, what's on your mind?
Just curious to understand if the product they developed, is it an add-on on a laser, or if is it just including also the laser source?
Yeah, Giuseppe, thanks for the question. I already, let's say, put it into the chat, but it is an add-on to your laser system, your laser source. It is, let's say, can be integrated like other, let's say, optical heads for SLM or whatsoever.
Okay. Yeah. No, I was just asking this because we are a distributor. We are added value distributor, And we have a small lab on which we play with femtosecond lasers. So let's say my point was just to understand if there is any possibility to test your equipment directly here, just to understand if there is any kind of market.
You are one of the best laser distributors that we have in Europe, Giuseppe. Do you have one slide to share with us of what you do? Because I really want more of our EPIC members to work with you.
I don't know if you see my screen now.
Crystal clear.
So basically, this is our workstation, which is an assemblage of products that we distribute in order to share with our customers, and that are mainly integrators, what we are doing. We, let's say, create this small workstation that is meant to show what we are capable to do. And on this, you can see there is a 40 watts carbide laser from light conversion with the 3 harmonics. We have a Alio system XYZ, plus a ScanLab head and the DMC software and the machine vision. So basically what we do, we put together all these things in order to show the capabilities of the equipment we sell.
But what makes a difference with OPTOMAN and any other distributor is that they integrate your laser into a real working system to show it to your end customer. And that's very unique, Giuseppe. That's very unique in this industry. I want to help you because what you're doing really, really inspires me. I want to go to one final question for Fusion Bionic team. I cannot congratulate you enough for what you're doing. All the way from Freiburg, Fraunhofer ISC wants to work with you. They say, what scan field sizes have you realized thus far, at what processing speed thus far?
Yeah, okay. So let's say the process for a scanning head, let's say with a different solution, probably the scanning head is meant. Let's say it is a little bit dependent on the feature size which you would like to achieve. So what we can have, for instance, with the scanner goes down to 2 micrometer. So you're invited to have a short look on our webpage. So there are some more specifications, let's say, shown, but of course there could be some tailored system if smaller feature sizes, so 2 micrometer, smaller than 2 micrometer is needed or are needed. And the scan fields are, let's say, in the range of the normal scan fields of the scanner.
Tim, I love the black processing of the glass. The person from Israel, he's going to contact you, Alofir, he's going to contact you for a collaboration on this. But I think we need the system integrator to discuss. So we have Lasea, I believe, in the room, right? Jose Antonio? Yes, Jose Antonio from Lasea. I know you have been developing a laser-based process for developing black functionalization of glass. Do you think there is some kind of room for cooperation here?
Sure, you know very well, we are very open and active in collaborative projects, European projects. The first one that comes to my mind related to this is Lampas, that I saw the logo somewhere in the screen. Where
you saw very well. That's very good that you're announcing it.
Yeah, it's one of the projects dealing with the kilowatt range femtosecond or picosecond ultra short pulsing technology because of the question of the coherency and doing interferencing to achieve a new world record on surface functionalization of different types, hydrophobic, black, antibacterial, etc. But we have many other projects on the way talking on.
And you have started so many collaborations with the big member on that team. You are in the right hands with Lasea. Francesca, how do we close this fantastic meeting?
We close this fantastic meeting talking about the real business couple, because so far we build them, but the last one is a real business couple, because we have here Sarunas Vaskelis from Dariusz Machining Control, the master of software that we heard already from OPTOMAN, by the way, that is doing for machine control, and our Mark Turner that was brought by DMC and explaining how he can use Dariusz Machine software and also his technology, right? So I'm really happy to give the floor first to Sarunas and then to Turner Laser. But first, Sarunas. Sarunas, are you there?
Yes. Hi, Francesca.
Hi.
Thank you for the warm welcome and everyone. So it is always fun to be part of EPIC event. And today I'm especially happy because we are warming up for our partners, Turner Laser Systems. And we work together for quite some time, and we know them as extremely professional and with lots of laser micromachining experience. So it's simply joy to work with them. So I cannot wait long to hear Mark's presentation. But before that, just a couple of slides to answer the EPIC questions on the behalf of DMC. So let me
You can share your screen. Yeah, exactly.
You should see it in a second. And first question is, what can we do for you? And what we do is software for laser machine control and for a wide range of applications. As you can see in the pictures, from 2D to 3D, all the way up to 5 or 8 axis machining. And it's from drilling and cutting to texturing and processing freeform surfaces. And for R&D and up to reliable industrial solutions. So the software is more than just the CAD/CAM. It does not really have an analog out there. And we are different because we do not just generate code that you can just put into the machine to run, but we control the machine directly and take care of all the process from CAD import or creation up to the final part. And we try very hard to make it easy to use. So the user just imports the drawing, draws it, and sets process parameter from the perspective of the application, and then just clicks run, and DMC takes care of everything else. So we are also hardware independent, and that gives our users resilience. So, you know, you can change the component without any additional development, and user interface stays the same, and so on. And another big benefit, and maybe the biggest, is that comes with DMC is the reduced time to market, because we take care of one of the most complex parts when making a new system. So the software that controls the whole process and the algorithms behind that. And we work hard so that your solutions can reach the end users much faster. And that's I think the big value. And what you can do for us is we are currently working a lot on 5 to 8 axis processes, and 5 to 8 axis laser processing is still quite a new thing. And there are just a handful of companies that are offering solutions. So paving path is not that easy, and we would appreciate some insights from the actual users, how things should be, how things should work, and how the things should not work. And another thing is we are also having a fully equipped application lab for testing, and with a couple of laser workstations, with all the components that go into that are relevant for us as well, as we are rapidly expanding and adding new workstations and so on. And also, we are always keen to try new things and then to suggest those solutions to our customers when we are looking to solve their problems. And that's basically 3 points. And that closes my part.
Perfect slide. Thanks a lot, Sarunas. Thanks a lot for this introduction to your epic slides, but also for Mark Turner, right? So Mark Turner Solutions directly from California. So the floor is yours. So we don't hear you, so I don't see you you might be muted, I bet.
Oh, I'm on mute, you forgot your mug.
Yeah, now we hear you and see you, very good. The floor is yours, Mark. Well,
thank you, Francesca. Thanks for the invite and bringing us over into this epic conversation, and Sarunas as well. I appreciate your introduction. I just want to say I'm really impressed with how collaborative and creative this has been as a discussion. So look forward to talking with more of you upcoming. So today I'm going to be a little bit different. I thought I'd go a little bit non-technical today, just talk a little bit more about integration as overall, and talk about some of the customers we're looking to work with and suppliers as well, what are the types of suppliers that we're looking to partner with. So Turner Laser Systems, we're based in Silicon Valley here in California, and we work with a lot of end users who have a vision, and I'm glad Sarunas brought it up, but getting time to market is absolutely critical. So we work with a lot of product developers, being startup companies who've got something new. A lot of times we're working with big Fortune 500 companies who have maybe a new product that they're trying to release for the year. And a lot of the times, the most thing that we have in common is we work with visionaries who have some sort of idea and concept for their product, and they're trying to get into short-term and long-term manufacturing in 6 to 18 months typically. And so this is the challenge of taking a lot of these ideas and concepts that we've talked about today in this micromachining a lot of the projects we work in kind of starts off where someone has, cut a product, drilled some holes, done some early feasibility work, And we see a lot of customers and end users end up in what was called as the valley of death. And I think a lot of people here, albeit suppliers or custom integrators and end users, have all experienced this valley of death at some point in time. And something I really want to encourage as a community is for as working through this with end users particularly, and breaking things down into sort of phases. And this is something that we do a lot of the times with our customers. We find that this methodology of breaking down this manufacturing challenge really helpful for the user and also the integrator as well. And so we like to do the early fundamental science of working out, is this a UV laser, an IR laser? We're talking femtosecond, nanosecond, and then thinking about how that's going to impact the volume production and what the machines are going to look like. We spend a lot of time working with our customers, hundreds of hours, sometimes thousands of hours of refining the processes to make the parts to specification, and then walk with them on qualifying what is it going to look like in terms of throughput and yield. And there's a lot of work that needs to go into the materials analysis on this side as well. So just a little bit of an introduction there. It's only when we get this sort of work done with our customers that at that point we start to approach what type of machine we think is going to look like. A lot of times it's driven by what's the form factor of the product. These massive solar panels that we're loading into our machines, are these small little medical devices, are these something that needs to be done on a wafer level with wafer automation. A lot of that can sometimes drive even the fundamental science when we're thinking about what type of laser to use. It's really good to know that early on in advance. And that's sort of our general philosophy for how we like to build our laser machines and get the right tool for each application. So just a little bit more into sort of our product. So we build laser machines. Sometimes it looks something like this, which is pretty standard laser in a box with all the components you need inside. Sometimes it looks very different. Again, it's driven by the manufacturing architecture and whether or not this is going to be a roll-to-roll system, wafer handling system, or the drive of the application there. For our suppliers that are out there, we're always looking at new types of lasers and beam delivery systems, how we can improve this for micromachining applications. We also do a lot of work on part handling. It's just as important, I find, how to fix your parts, how to handle debris. I think there were some topics and conversations today about how to make things cleaner and how to have a nicer, smoother finish and things like that. So there's a lot of work that can go into that in terms of debris management. And then in terms of automation, safety, sensors, motion, vision, automation, software as well, which I'll bring up in a moment. But the main lesson that we've sort of learned is choosing sort of a platform driven usually by the manufacturing requirement. And then, I think Demetrius had really broke it down really well too in his topic from Oxford Lasers, how they develop their process as well. We find a similar sort of philosophy of developing the process first, understand it, and then building a custom solution for each of these applications works really nice. I always like to tell my customers and partners that we work with is a lot of these lasers that we're working with today are some pretty powerful femtosecond lasers. It's great to see how much power is available, high pulse energy, hundreds of microjoules and tens of watts, even up to 100 watts of femtosecond lasers now, which is great. And we work a lot with nanopico and femto. But I always like to say you're only as good as your ability to control your laser and to control your pulses. And our partners at DMC have been amazing in working with us on each new application. And it's very collaborative. And so we work with their team to sort of problem solve, because software is often one of the key components to solving these problems in manufacturing sense. And so we'll not only consider what are the hardware requirements for the machine, but also the software requirements. And often the software can drive which hardware components you end up using. So just a little bit of insight there, but full suite of features that we use. Just really briefly, the types of processes that we like to work with. Micromachining is a great space for us. Microablation, cutting fine features and thin materials, dicing wafers, drilling small holes, ear hole drilling in a variety of different materials, particularly in the semiconductor space. We do etching in glass and other dielectric materials. And we do welding such as dissimilar metal welding, but we also do fusion glass welding for the medical device industry. And I did want to throw one technical slide up on here. Here's an example of one type of process that we developed, and here's some sort of fundamental ablation results that we got for femtosecond laser rounding of dielectrics. And this is something that we've seen a lot of interest now for medical device customers who are making these implants that go inside your body. So in that case, you want things nice and smooth, no sharp surfaces that can insert easily. Also in the consumer electronics industry, they're always looking at better ways of making things feel good and look really good at the same time. And so these femtosecond lasers, the thing that I've been impressed with is in the last 5 years, how much power we have now. And we can do processes where we can cut these materials, full cut through, and round them in a single process. And the shapes is something that we can control, so we can put in a mathematical equation saying, okay, that's my surface shape that I'd like to have, and then the software can come in and it just sort of works it all out for you in terms of how much laser exposure and how to distribute your pulses. So that's a really nice feature that we're able to achieve there. Something I think that's really important to touch on as well is understanding how is the automation going to look like in high throughput volume manufacturing. And I think one thing that we've learned is to bring in automation partners early into the conversation. So as we start to talk about what type of laser to use, even at that early stage, it's great to know, is this going to be a roll-to-roll process? Are we going to be loading this with 6-axis robots or an EFEM? Does it need to be done in certain environmental conditions? And we partnered with Owens Design, so Turner Laser Systems. We are actually built and based inside their manufacturing facility here. We've got about 5,500 square meters of manufacturing space. And they've been doing precision automation and materials handling for about 38 years now. And one of their claims of fame is successfully delivering 100% of their products over that 38 years, which is quite phenomenal if you think about the types of emerging technologies that they've been supporting. So who do we like to work with? Sort of rephrasing your question there, Francesca. I think for end users, we're always looking to collaboratively partner. If you're looking for a trusted advisor who's not just going to build the machines, but help you develop the processes, turn that into automation, and then building turnkey solutions. We build both manual tools as well as fully automated tools. We're always looking to meet new customers and end users in this space. And then for suppliers, we're always looking for unique technologies that are serving micromachining industry, suppliers who are creating new value with their subcomponents. And if you're looking for systems integrator partner who's going to be driving projects and helping take your product into advanced manufacturing solutions, we'd love to work with you. Thank you.
Thank you very much, Mark, for a great presentation. And thank you for coming to this meeting with the right mindset. It's about cooperation. And we have something called the epic question, which is what can you do for them? What can they do for you? I'm going to rephrase into give me one challenge, one item in your Santa Claus Christmas list that my 700 friends can help you with.
I think we're always looking at more into beam shaping. I think beam shaping is something that we sort of understand on a fundamental level. We've seen beam shaping as an opportunity, for example, improving the surface finish. Having just Gaussian beams still seems to be, I'd say, 90-something% of applications in the micromachining space. And I think there's a lot of potential in beam shaping and more collaborative work, I think could help in that regard.
You knocked on the right door, and I actually want you to come more often to our meetings because beam shaping is really our bread and butter. We really, really love this. I want to go back to DMC. When we have the control part of the workstations, we work, and I already introduced to many workstation manufacturers. For direct machining control, what would you say is the biggest added value that you can provide to all these workstations, and what kind of challenges would you like to hear from them?
So the biggest added value is that the workstation builder can worry much less about the software and how to control all the orchestra of devices. And for example, I have a good example for researchers, and this applies to the OEM customers as well, is that, for example, you can just simply take a bunch of hardware that you can get off the shelf, which is readily available, and then you take the software, and then you can work with the software in the way that you just import your drawing that you draw with some simple SketchUp, let's say, some free software, import into DMC, define a couple of parameters that you understand what they mean, so like power, size, position, and so on, and click run, and software handles everything. So
one question for you, coming all the way from the YouTube universe, actually one machine manufacturer who didn't want to reveal who they are, he's wondering what hardware can you control, but most important, how much programming is needed?
So we can control a very wide range of hardware. So I don't know, for motion controllers, for stages, let's say the most popular ones, Aerotech, ACS, Newport, Delta Tau, and so on, and all the most popular Galvo scanner controllers and lasers and so on. So it's a very wide range of hardware, and it's available we on our website. I think that's the best way to check. And
how much programming is needed? Do you want coders to use it, or can anybody do it? Yes, tell us.
Exactly. So you don't need any programming at all. So you just draw shapes, you input positions, you import.
I'm going to do an exercise now, Sarunas. I'm going to introduce you to one laser manufacturer, and let's see how we can control the software. We have EdgeWave in the room, right? Kemin Du is with us. EdgeWave, you manufacture the Inos Lab laser for glass processing. So Kemin, could you tell us about your laser? And then we're going to go to Sarunas, how this can be controlled into the workstation.
Yeah, I just want to show you one slide and say what we can do. We can provide service the community of laser microcontrolling. I don't know if you see this, man.
It is coming. It's almost here. I believe it's about to arrive. Here it is. Yes, please go to slideshow mode.
So you see my slide?
Yes.
This is, we are EdgeWave. We are make short path lasers and ultra short path lasers. And this is slide just summary what we can do. We can provide the service to our community. And our laser based on Inos Lab technology. This is a kind of technology developed at the front of Institute of Laser Technology and proposed by me 20 years ago. And now we are making a commercial product. And the product range is quite broad, and beam quality is high, can M2 1.1, average power up to 600 watt. Right now we have 800 watt, and the pulse energy up to 3,000 microjoule. The big number, this 3,000 microjoules is respect to the ultra short path lasers. And the nanosecond laser, we have 100 millijoule. And the short path length go from 1 nanosecond to millisecond. And it's continuous adjustable. And we can, ultra short path laser, we have go down to 300 femtosecond. We can have several picosecond and 12 picoseconds, our standard picosecond laser. Using based on femtosecond basis, we can go from 300 femtosecond to 20 picosecond continuously. And the peak power up to 3 gigawatt, and the high repetition rate, we have 1 megahertz, 100 megahertz, we are already gigahertz laser right now. And flexible triggering and the free triggering, this is our patent technology. And this is that means this kind of technology, I understand Oxford looking for time engineering, we can do free triggering, and with time delay like 20 nanosecond by 50 megahertz CEDA. If we use 100 megahertz, we have 10 nanosecond jitter, and then you can free do what you can. And laser or laser integrated modulator, you can control the pulse energy from 0 to 100% for each pulse, up to 2 megahertz. And right now we have already up to 8 megahertz. We already have the product up to 8 megahertz. You can control each pulse energy. Okay.
I am a huge fan of the Inos Lab laser. I am a huge fan. I have been a user also in the past. We are talking on one of the key products of the European photonic industry here. Inos Lab is really one example. And Dimitris, I know he knows the product very well. Dimitris from Oxford Laser. I think there is a clear room for cooperation. Sarunas, how do you interact with laser manufacturers? These guys have a fantastic laser. How do you, when you come up with this product, what is your next step at DMC?
So we would have to implement it in DMC, and that usually takes maybe 5 to 7 days of development. So in a week, you could have this laser ready in the software. And then when you design the process, you simply input, like you select the beam profile, you input the power that you want, you input the burst mode, and you change that from shape to shape, from part of the object to part of the object in the most flexible ways that you can think of. And yeah, so
Sarunas, congratulations on DMC. Congratulations on what you are achieving. You are making an impact on connecting laser industry with workstations, and you are one of the jewels on this association. And congratulations Asfericon on their 25-year anniversary today. It has been a really, really great meeting, 2 hours and 15 minutes. So sorry about these 15 minutes, but we really talk about all the challenges that we had on the laser micromachining, and that was really, truly something fascinating. It really fascinated us. I would like to say that we're going to continue organizing these meetings because we really want to find more challenges from end users and keep connecting people. This is what these meetings are about, connecting people. Please register as soon as possible to the upcoming meetings, and also tell us in advance if you want to show one slide. Remember, EPIC members can always share one slide at our meetings. Can always share one slide at our meeting. Just have to tell us in advance and we'll make it happen. Remember that also in a couple of weeks we have our VCSEL meeting, and that's going to be spectacular. So you can actually manufacture VCSELs or package them, or actually put DOEs on top, do wafer level packaging testing. Register as soon as possible to our VCSEL meeting and to any other that we can, because all I want to do is to connect you and then get some vaccinated, wear a mask, wash my hands, and travel again. I can't wait to start traveling again and visit Jena to have a drink with my Asfericon friends. Until the next time, see you soon. Bye bye.